All right, so today we're going to be covering topic 1, which is MATLABBasics, and I'm also going to be kind of introducing the goals and motivations of the course. The homework that you have, I'll always put up on the board, but please note that it's always in the schedule. Everything is laid out in the schedule on the last page of the syllabus. So by lab next week, so that means either your Monday or Tuesday lab coming up here in a few days, you need to come with your pre-lab 1 done. And that's the material that we're going to be covering in lecture today. One announcement is that they changed our lab room for lab section 3, which is the Monday morning lab. So we're now in EPS 134. They're very close to each other, but the labs are always in 129 or 134. So if you ever get them confused, just try both rooms. They're right next to each other. I think that is it. Oh, and the way that I write this is I'm referring to the week on the schedule in the syllabus. So there's a week number associated with each one since you're all in different lab sections. So I'll always just refer to the week number of the lab rather than the actual date for the due date. Okay, so I'm going to start today by talking about sort of the course outcomes. It's something I skipped on the syllabus on purpose because I want to point out the specific things that we're going to be working on in this class. So these are basic skills that we're going to be developing throughout, and I think it's good to distinguish between some of these in case it's new. It's in a totally new area for you. So you'll notice on course outcome 1 in the syllabus that I'm looking for a proficiency level that's introductory for programming, and that's one of the big motivations of this class is to teach you how to program in general, not specific to any language. In course outcome 2, you'll see that I'm also looking for you to develop the skills and techniques needed to use both the MATLAB software and the environment and be pretty proficient in the syntax of MATLAB, which is the language that we're going to be programming in. And that is something that these two things are independent skills that we're going to be working on. So if you can develop good programming skills, you should be able to adapt them to any programming language. MATLAB is unique in that it's not just a programming language, it's also a computing environment and software tool that has a lot of other things that you can do with it, and that's what we're going to be talking about a lot today. The third outcome you'll see is some of the topics that we are choosing to apply our programming skills to. And this is something that varies this is a big difference than if you took this course, for example, in a computer science course, which is a lot of times what engineers, where they learn to program. Because you're taking it within an engineering department, we are going to be looking at mathematical and numerical topics that you'll see in engineering all the time. A lot of them are statistical. The numerical topics that we're going to be using are all based off of Calc 1. Assuming you've done Calc 1 and some Calc 2. So there's a level of application that I'm looking for you to be able to apply these to engineering problems, basically. And then I'm going to skip 4 and just go and highlight outcome 5. And this is more general than any of the other outcomes that we're talking about, and this is something that I hope all of your engineering classes help develop. But we're going to work on improving your problem-solving skills and being able to look at a problem and be able to find which numerical techniques, which mathematical techniques, and which programming and algorithmic things you need in order to solve that problem. Which is what all of the labs are focusing on. They're a lot more open-ended than the pre-labs. Okay, so I always like to start by highlighting 4 things that are often mixed up in a programming class, and I would hate for you to leave this not being able to distinguish between these 4 things. So the first thing is this idea of programming. The second is syntax. There's a lot of mistakes there. We're going to start over. Syntax or language. The third thing is logic and algorithms. And the fourth is the MATLAB environment. So I just want to talk a little bit about these 4 things and what we're going to be covering in these areas in this class. And some of it we start today and some of it we don't. So programming can be a way, the most general way to think of programming is it's the way that a human communicates with a computer. It's the connection between binary and words. So you know what you want to do in words? Programming gets you to have a computer do that with its binary language, which is all it knows. And it's a general thing. It's this idea of learning how to use loops and conditional statements and data structures and arithmetic and combining those in such a way that it can solve a problem. And so that's a skill that is actually needed now or useful in almost any area that we're going to develop. And I just like to point this out because it is heavily emphasized on the tests. That's heavily what we're trying to learn is programming. The syntax is the language. So other languages you might have seen or used are Fortran, C, C++, Java, Python, and they're all usually kind of historically used in certain disciplines for different reasons. Some web-based applications have stuck to some. A lot of computational sciences have stuck with Fortran. It just kind of depends, but it's just a language and it's very transferable once you have programming knowledge to go between the two. The logics in the algorithm is really generating like a stream of logic that allows you to solve the problem, and it's very dependent on the problem. So for example, if you were told to create a computer program that could have the computer guess your age, the algorithm would be what series of things do I need the computer to tell the computer to do in order for it to be able to do that for me. And then programming would be the flow that you use in order to do those things. So maybe you would say, I need it to do this many times. That's in the algorithm. I need it to ask me many times. But then for programming, that means you need to use a loop. So the last thing is the environment, and that's what we're going to spend a lot of time today looking at. That's what's probably most confusing is MATLAB is not just a language, it has a lot of other features that are useful for you in all of your classes actually right now, but also in your future career. It can be used for, it has just a lot of use. So that's what we're going to start with today, is talking about the environment. So what I'm going to do is I'm going to actually summarize what I am showing you on the screen on my notes here, and then I'll switch to MATLAB so that you have this in your notes, and then you can look at what I'm doing in MATLAB. This is the part that can be a little bit quick, so you can go back and look at the video if you miss anything. So the first thing I wanted to tell you is what MATLAB stands for. And MAT stands for matrix. And the reason it's called MATLAB or Matrix Laboratory is because MATLAB is designed in such a way that it does really well with arrays of data. So the way that it's designed in the back is that it basically can do operations on an entire array as fast as it could do operations on a single number. So instead of just calculating kinetic energy or something with velocity, if you needed to do that with one velocity, it would take MATLAB just as long to do it on 100 velocities in an array. And that's its strength. So a lot of what we do in this class is learn how to use that capability of MATLAB, the array capability or the matrix capability. So let me switch over. Ooh, maybe I have too many things open. To MATLAB here. And when you work through the pre-lab, a lot of what I'm doing, you're going to repeat or do something similar on your own. So I'm just trying to kind of introduce it to you for your first run through, and then when you do it on your own, it will really help. So I wanted to first just familiarize you with the environment and show you what the different windows are and what they do. And I'll switch back over to this. My computer's not too slow. So there's a couple different things. The first thing is the command window. The command window is where you execute all of your single line commands. And it's mainly used, you can think of it as it's just like using a calculator. So anything you would want to do in your calculator, you can do directly in the command window. This is a feature that most programming languages don't have. You have to actually write something in an executable file and run it. So anytime you're kind of developing code, you can try it out in the command window, but you can also use the command window for anything you would use a calculator for. You'll see that whatever command you put into the command window, so if I just have a few, the command will automatically put the output of whatever you entered into the command window into the variable called A and S. I think a lot of calculators do this too. So it stores that last executed command, I guess you could say, the output of the last executed command. The other thing you'll notice is that there's this window called your workspace here. And your workspace is going to hold any variables that you've used inside your command window. So right now we only have the default and S1, but you'll see in a minute when we start doing other ones, the other variables will show up here. The current folder is your active directory that you're in. If you want to run an executable file, the file has to be in your current folder. This is actually sort of dependent on the operating system and the computer that you're running on. MATLAB has gotten better at this. So now if you have a folder within your current directory, sometimes it can find the executable within that folder without a direct path. But your safest option is to always use a direct path and only run things from the folder that you're in. This is probably something we'll do we'll do towards the end of the semester, is create a tic-tac-toe game. So this was one that I created last semester. And so to run that executable file that I wrote, I just typed in the name of the file in the command window. So the command window is where you also execute the files. This one requires inputs, and it takes a while. It's not a perfect game, but it works. Okay. Some other environmental things that I want you to see is where you actually do the text editing. So if you clicked on a new script, or if you click down on the new button, there's a couple different forms of a script that you can start with. But if you just click on new script, you'll see a new window pop up, and this is called your editor. This is your text editor, and this is where you actually write out the code. So if I open up my tic-tac-toe code that I already wrote, that is the executable file, and this is something I wrote in class towards the end of last semester, or I should say the whole class wrote it together. What other windows? Command history is not showing up. It must not be used anymore. Another one that's useful is the help window. So over here, you can just click on the question mark, or you can search documentation. The help is really slow, so I never use it actually. I just Google, because the web-based version of the help is much faster. But it is here too if you need it. And then the last thing that you'll start using eventually, or if you are using MATLAB now for other things, is the figure window. And so if you want to plot something, that figure window will pop up. I could do like some really exciting plot for you so that you can be really motivated to be able to use it. I'll plot the cosine of x. Should probably have used a little more points, but that's what it will look like. It pops up in a separate figure. And there's a lot you can do with plotting. Again, this is a feature of the MATLAB computing environment that's not typical in a programming language. Typically, you have to use a separate software to post-process and visualize data. Yeah.
Would you use a different? Would it do different? Would it be a different window for like if you did a three-dimensional thing versus a two-dimensional?
It actually is the same window, but yeah, it would look different.
Okay. It would look different.
Yeah, it would look different. So you can have multiple figures. Every time you type figure, another figure window will open. So you can have more than one. If you don't open a new one and you plot something, it will overwrite the figure that's open. It always just uses the most active figure. And MATLAB does have line plots, a bunch of different 1D plots. It has 2D plots, either surface or contour plots, and then it has some 3D visualization, but it's really limited. And I personally, well, actually, you know that video I showed you? Did it ever work where it was like flowing down the slope? That was made in MATLAB. And I like kind of was frustrated because that was the most I could do with 3D visualization. I couldn't do anything else to make it look better. So I'll typically use ParaView or TechPlot for 3D visualization because it's a lot better. Okay, so I've shown you the windows, and then I've showed you how you can use MATLAB as a basic calculator. I also want to show you a few shortcuts, and I'm going to write them down after I show them to you so that you have them because they're very useful. The first thing is that MATLAB has a bunch of intrinsic functions, and you just have to get used to the syntax of them. So, for example, any of the trig functions are already in MATLAB. So I showed you cosine, there's sine, and then those are defaulted into radians, so you can also do cosine d to do the degree equivalent of the trig functions. But like anything like that is already in MATLAB, anything you could think of. Pi is already there, an exponential is already there, etc. If you want to try something without using the help, the first shortcut I want you to be aware of is the tab key. So let's say you wanted to do, you wanted to take the average of something, so you just started typing out mean because you thought maybe mean was an intrinsic function. You can start the word, press tab on the keyboard, and it will show you everything that starts with those letters. And there's a lot, obviously, with ME. The more you complete, the less it'll show. And this includes, it'll also autocomplete with anything that's in your current folder. So if you use a long name for your file name, you don't have to type the whole thing out. You can just start the file name and then tab the rest. So the tab is the first shortcut that's really useful. The second one is the up and down arrows will toggle through your history, so you can see and it actually goes beyond just the session that you're in to previous sessions. So this is a session before I started. I use MATLAB as I only use MATLAB. I don't have a calculator, so any calculation that I need to do, like whatever, for taxes or just anything, I just use this. Don't make fun of me if I have like 3 plus 4, what is that? But anyway, up and down toggles through previous commands so you don't have to retype commands. A lot of times you try something, you need to just go up and change one letter, so you could toggle up and replace the letter and re-enter it. Another thing that can happen is that you could be within the a double-lined, a multiple line command, so like a loop. And when you do that, you'll see that the arrows go away. So you see how I don't have arrows there anymore. So I don't want to finish the command, and I want to just get back to the arrows. To get rid of whatever command is being executed, like the cancel, is Control C, and that's on both operating systems, Mac and PC. That is really important tip because a lot of times your code will get stuck, or the code will freeze, and a lot of people default to restarting MATLAB or restarting their computer. But typically, all you have to do is type Control C to get out of it. And then the last tip is to clear out commands. You just type the word clear. So if you saw here, my workspace just got erased. You can also type clear all, and you can also clear specific things, which I'll show you in a second. So I'm going to move over here and just summarize some of the things we just talked about. We talked about the Windows, MATLAB as a calculator. And then I'm just going to jot down the shortcuts that I showed you, which was the tab, the up and down arrows, Control C, and clear. All right, the next thing I'm going to show you is using variable names in MATLAB. So most of the time, if you're actually writing out some sort of program, you give every number that you use a variable name and refer back to it. And so you can use standard, just like letters, A, B, C, whatever. And you'll see that those are showing up in my workspace. Right now I'm just going to stick to scalar quantities until we do arrays, which I think is next time. But once you define a variable, then you can use that variable to do the same arithmetic or whatever it is you're doing, and it's stored. That number is stored in that variable. There are some variable name conventions that you have to be aware of. The most important one is that any of those intrinsic functions can be used as variable names. So I can write over cos that we just used with the variable. And now if I try to use that function cos, it's not going to let me anymore because I just overwrote that entire function with my new variable too. And so it's a common thing that happens that is very hard to debug. So you always want to check before you choose a variable that it's not already used as a function name. And there are quite a few, so the trick is to just go in and use the tab to check the variable name to see if it exists. And if it doesn't see it, then it doesn't exist. Any questions about that? Yeah.
So if you accidentally use a function as your variable name, how do you undo that?
Yeah, that's what I was going to show you. So the clear clears all of them. If you only want to clear the one that you just wrote, you just can clear that one variable, and then if you try it, it'll work. But clear all erases anything that you wrote over. It's nothing permanent. It's just if you're writing a long function and it's not it's one of those things that happens and it just doesn't make sense because it's not like an algorithmic mistake. It's just so it's typically a pretty hard thing to find. I think the only way is to just Google. You can just Google the variable name you want and see if there's an existing function. Go into the help and Google that name, or do the autofill. So just type in cos and then tab, and you'll see that it's already there. Yeah.
Is there a debugger?
There is a debugger, and we're not using it, but we probably should at some point. I'm kind of old school and I just do my own debugging, but there is a debugger in MATLAB. Okay, any other questions? Okay, yeah.
You didn't know the command say the
I don't think so. It's not that smart yet, but it's getting there. I mean, there's a lot of things that I used to like have in my lectures, like, oh, you can't do this, or MATLAB will mess up when you do this, and now it works, you know? So they'll probably do it at some point with new versions, but not currently. That could be something that's in the debugger, though, if you did something like that. So I can show you that, actually. So the last thing I want to show you with the MATLABBasics, before we go over the method that I want you guys to use for this first assignment, is how to write, save, and run an M file. So if you open up that script file and save the file as some name that you'd like to use, and I showed you already with the tic-tac-toe game that to run the file, you just can start writing the name of your file and then press enter inside the command window. Right now my file doesn't do anything, so it's just empty. The other option for running an executable file is to press run right here. That runs it as well. The only reason I use it all the time, but you have to be careful because we're going to start writing functions that are going to have inputs, and the run doesn't work anymore if you have inputs. But when we get there, I guess we'll talk about it. But those are the two options: typing it in here, pressing run. I think you can also right-click on the file and run it here too. So we're going to write out a file that's sort of similar to the first one that you're going to write and run it. So we'll do that right now. And what I'm going to do is, if you look on my computer is struggling. I should close all of my windows. So if you look at the last page of your pre-lab assignment, you'll see that I've written out 6 steps that I'd like you to go through before you come to pre-lab. The steps basically have you read the lab and write out a pseudocode before you come into lab on how to do the program. So we're going to do an example of that. So step 0 is to read the problem, which, you know, you have to do. And then the first step is that you need to solve whatever it is the programming assignment is telling you to do human style. So that means you need to think through what the solution is if you were to do the solution on your own. Now I have to just warn you that this is a very difficult thing to do on the initial assignments because they're so much more straightforward. But if you just practice the exercise, it'll make it a lot easier for when we do the really difficult problems. And basically what happens a lot of times is you're given a programming assignment and you read it, and a lot of students come to me and they're like, I don't even know where to start. Like, I don't even know, like, I feel lost. And so I created these steps as a way to kind of step you through the process. So solving it human style, for example, what if you had to write a max function, a function that's able to take in a set of numbers and tell you which one is the maximum? I would have you go through a set of 5 numbers and actually tell me how you would find the max and write down the steps that you took to do that. Then after you write out the steps of how to solve it, you convert the human steps to computer steps. So for example, if you one of your steps is that you need to report back what the answer is, then you'd convert that to a computer step, which is to use the display function. Or if one of the steps was to determine whether this one is bigger or this one is bigger, then you would use a conditional statement. So it kind of steps you through that. The third step is to write out a pseudocode. So a pseudocode is sort of a draft of the code that you're going to write, and you don't worry about syntax. You just write the order of steps that need to be taken using the computer equivalents of all of the things you just came up with. So in these steps, the order might not be right for a computer. So the order that a human takes might not be the same order that which one did I just say? They just might not be the same order. So the pseudocode allows you to place them in the right order. A lot of people like to use like block diagrams or very visual blocking, and some people like to just write it out in words. And so I'll show you a couple different ways to do it when we do them, but it's sort of like a draft of your code. And then what you're going to do is write it out in MATLAB syntax. And this is all something you should do before you get on the computer, before you start writing. Now, this is my advice to you if you're feeling overwhelmed by the assignment. If the assignment is very obvious to you, then you don't need to do all these steps. But I've created these steps to get everyone up to speed by the time they come into lab. Everyone should be ready to write the program when they come into lab. And so we're going to check that you've done these 3 steps. So if you think that you don't need to do the first 4 steps and you can write out a pseudocode, then you should come to lab with your pseudocode written so that we can look at it before you get started and be able to kind of gauge how much attention we should be giving you to kind of help you through that assignment. And it really, really helps us in the lab make our time most effective because helping people can take a variety of amount of time. The last step is to just jot down any questions you have that you would like to ask one of us. For most of the labs, there'll be 3 of us in there so that you're kind of prepared to figure out anything that you're still questioning. Okay, so this is what we're going to do. It's really hard to write a program when I haven't taught you anything yet, but we're going to give it a shot. So we're going to write a program that has the computer guess your age. And so we have to kind of think about how we as humans would do that. And it sounds weird, but the first thing that you would need to do if you were going to ask someone what their age is you would, or if you were going to guess someone's age, is you would need to tell them that you're going to guess their age. So the first step that I would take as a human is proclaim that I'm going to guess your age. And then the next step is to guess a number. And then the third step is to tell them. Tell the number. This is really, it's just dumb, but this is what I'm doing. So we're going to write this program. So these are the human steps of the task that we're trying to accomplish with this program. And so we're going to convert it into computer steps, and I'm also going to give you the syntax at the same time. So I want to use what's called an input function. It's basically a function that prompts the user to ask the first question because I want to alert them that I'm going to do it before I actually do it, so give them a second. The next thing I'm going to do is have the computer randomly pick a number. So there's a random number generator on the computer, and the function that does that is rand. But since we're going to just stick with a year, it's rand I, which is a random integer. And then at the end, we need to report to the user what number we guessed. So we're going to use the function disp, which is a a function that displays text to the user. So I'm going to move over to MATLAB and write this function into the program. And I'm going to do it step by step and run it in between so you can see. So the input function, and you haven't learned about functions yet, but it's basically a command that you type the word input and then in parentheses you place whatever text you want to prompt the user with. So we're just going to tell the user, I am going to guess your age. And then I'm going to say press enter when ready. I'm saying that because the way that the user prompt works is that you have to press enter to move on to the next command. And that's why I picked input instead of display for this, because I want to give the user a little bit of warning before we move on. So that's the first line of code, and I'm just going to run it. And you can see that my text that I just typed goes onto the screen and displays what I wrote. And then when I press enter, it finishes the rest of the code. The way that the input actually works is that it allows you to get input from the user. So if you put a variable name in front of the command, so x equals, and you run the command again, and then I actually enter something in like 7, it records that value to x. We're not using that feature here, we're just using the enter feature, but that's what the input function does, and that's what you'll use it for in your programming assignment. So I'm just going to get rid of that because I don't want it. Okay. The other thing I wanted to show you is that when you start editing a file, so you see how the file is black here, and then if I change it, it turns blue. That tells you whether or not the file is saved. So if I didn't save it and I ran it over here, it would run the old version of the file. If you press run, it automatically saves the file and runs the saved file. Just a little difference between the two. Okay, so now I want to use this rand_i function. So I'm going to have to go over to the command window and just see how that function works before I actually use it. So if I type in rand_i, I get an error. So I'm going to type in help rand_i, which is going to bring up how you use that function. And so it looks like I have to also say how many random numbers I want it to provide for me. So if I do rand_i 100, then it's going to give me a random number between probably 1 or 0 and 100. So that's what I'll use. So I'm just going to assume the person is less than 100. And I'm going to give that a variable name guess. And then let's run it to make sure it works. I'm ready. Guess equals 91 was what the computer came back at. So it printed the guess because if you look here, I don't have anything on the command line. It's just open at the back. If I put a semicolon behind the command, what it's going to do is it's going to hide the definition, and so nothing will print. So this semicolon here hides the what do you call that? The display of the definition. So this line of code is defining a variable, and typically when you define a variable in your code, you don't want it printed. And if you want it printed, you print it later for some other reason. So by default, you'll always see that MATLAB will have this little orange highlighted thing at the equal sign, and that's because it wants you to hide all of your lines. It really slows down your code when you print everything that's happening. So your default should always be to hide it, and then if you choose to display it later, like we did in our step 3, you're just going to use the display command. The benefit of using the display command is it just comes out nicer. When you define something, it'll always come out with something equals space, and then it will print it, takes up like 4 lines. If you do it this way, it only takes up 1 line. So you can see here that the display changed. Now it's just the number. And that has it guess your number. You can do a lot more with this, and what we'll do in the future is I could provide the computer a yes or no answer of whether it's not right, and then it could keep guessing until it gets it right, and then it would actually be sort of a useful program because the computer could guess your age. But just to show you, I could just put a for loop around this, and I could have this run 100 times. And because I have the prompt in there, it's going to wait each time before it guesses again. And I could just have it keep guessing, and then I could stop when it's done. So that's what that loop does, is it repeats it 100 times. And so that's, I think, the fourth topic of the class. Do you guys have any questions about this? These are parentheses. Yeah. Any other questions? Yeah.
So if you're just trying to display text, you want to print definitions as well?
Yeah, so if you want to display before this, something like this, then if you just want to display the string, you would do that. Okay.
So, are we gonna